In 1933, Swiss astronomer Fritz Zwicky was hanging out with his friends in the California Institute of Technology when he noticed something weird. As he looked up at the night sky, specifically a galaxy cluster named the Coma cluster, he realized that all of the galaxies within it were moving way too fast. Like they should have flown apart long ago. He published this observation and proposed an explanation in a 1933 paper titled The More the Merrier. And while no one paid much attention to it at first, these ideas would eventually grow into what we now call dark matter, one of science's biggest mysteries. Before we can talk about how Fritz figured out that there is this invisible stuff all over the universe, we need to talk about the thing he was looking at: galaxies. When astronomers study galaxies, they often look at them from the side because that gives us a better look at their structure, including how fast stars are moving. If you've ever seen a spinning top, you know that a bunch of stuff spinning really fast has a tendency to fly off to the sides. Stars in a galaxy are kind of like that. If there isn't anything holding them together, the further away a star is from the center of the galaxy, the faster it needs to spin to stay in orbit around the center of mass. By measuring how fast a star is moving, we can use Newton's laws of gravity to work out how much mass is in the galaxy. This is important because the amount of mass in a galaxy tells us how strong its gravity is. The more mass a galaxy has, the stronger its gravitational pull and the easier it is for it to hold itself together. You can think of it like if you're trying to take a picture of your friends and you want everyone to stay in the frame, you'd want to bring a tripod for your camera and maybe some tape measures so that you can back up far enough to get everyone in the shot without them all running away. If you only had a few people in the picture, you could probably do this by hand. But if you're trying to take a group photo of like 20 people, you're gonna need some extra support. Well, galaxies are kind of like that. If they don't have enough mass, then they won't have enough gravity to keep themselves together. In that case, you could say they aren't really a group photo, they're more of a free-for-all. In the early 1900s, astronomers measured the speeds of stars in several spiral galaxies and used those measurements to estimate the amount of mass in each galaxy. But when they did this, they found that the stars seemed to be moving faster than they should given the amount of mass that they could see. It was as if something was pulling the stars towards the center of the galaxies, but astronomers couldn't figure out what. Was there some unseen mass that made up the majority of the galaxies? Or was Newton's theory of gravity wrong? Then in 1933, Fritz Zwicky came along and turned that question on its head. He wasn't studying how fast stars move within galaxies. Instead, he was looking at how fast galaxies were moving in relation to each other. See, Fritz was interested in galaxy clusters. These are groups of hundreds or even thousands of galaxies bound together by gravity. If you want to hang out with a bunch of cool galaxies, then galaxy clusters are the place to be because they are literally the life of the party. Galaxy clusters contain hundreds or even thousands of galaxies, and they are also home to an even greater number of stars and planets. They're just bustling metropolises of cosmic activity. So it makes sense that in the 1930s, Fritz wanted to find out how they worked. For the Coma cluster, he calculated how fast each of the galaxies in the cluster was moving relative to the others. Basically, how fast were they all moving with respect to each other, which allowed him to calculate the total mass of the cluster. Then he compared that total mass to the amount of mass he could actually see. And there was way more mass in the cluster than he could actually see. It was as if the galaxies in the Coma cluster were being held together by some kind of invisible glue. He didn't know what this stuff was, but he knew it had to exist, so he gave it a name: dark matter. In his 1933 paper, Fritz wrote that the hypothesis of hidden mass or dunkle materie seemed unavoidable. But unfortunately, no one seemed to care about his idea. Most astronomers thought that his math was wrong, that he had made some kind of mistake. Some physicists didn't like his idea because it went against Einstein's theories, and some astrophysicists were just plain mean. One called his idea incomprehensible, and another said it made no sense whatever, and it's not like Fritz was a stranger to criticism. Earlier in his career, he'd gotten in trouble for publishing results from an experiment that disproved a popular idea about supernovas. But instead of letting that stop him, he just kept searching for evidence to support his ideas about dark matter. In the late 1930s, he started mapping the masses of other galaxy clusters. He was looking for patterns that would point to the existence of dark matter. But then World War II broke out and everything changed. See, Fritz was born in what is now Switzerland, but was living in the United States when war broke out in Europe. But because of a law that barred immigrants from serving in the military, he was considered an enemy alien. By 1942, he was under arrest and heading to an internment camp in North Dakota. Eventually, he was allowed to leave the camp and resettle in California. But by that time, most of the data he decollected while in prison had been lost, and he never fully recovered from the setback. Unfortunately, this meant that Fritz never got the recognition he deserved for coming up with the idea of dark matter. That's not to say that no one else was working on the idea at the same time. In fact, in 1937, another Swiss astronomer named Walter Porra came to a similar conclusion while studying a single galaxy, but he never published his results. Meanwhile, Fritz was busy trying to prove that dark matter existed. And when he died in 1974, no one really cared. It wasn't until the 1970s that dark matter started getting a little less dark and a lot more matter. A couple of independent studies found evidence for dark matter in galaxy clusters, which reignited interest in Fritz's idea. Over the next few decades, more and more evidence piled up in favor of dark matter. In 2011, the first direct measurement of dark matter was made by the largest and most sensitive X-ray telescope in the world at the time. And in 2022, scientists announced that they had collected the most precise evidence yet for dark matter. Today, most cosmologists agree that dark matter exists, but no one knows what it is. We know that it's not made up of regular matter like rocks and people and stuff because we can't see those things. And we know that it doesn't interact with light because we can't see that either. In fact, we can only observe dark matter by watching its gravity affect other objects. Because of that, dark matter is sometimes called a hypothetical substance, meaning that while we believe it exists, we haven't actually observed it directly. But the fact that we haven't observed it doesn't mean that scientists aren't trying. Some experiments hope to spot dark matter particles created by smashing together billions of lead ions at near the speed of light. Others are trying to detect dark matter particles that occasionally pop out of empty space. Maybe you've even seen one of these experiments. There's one called xenon at a particle physics lab in Italy that uses supercooled liquid xenon to try and detect dark matter. Their detector is housed inside an underground chamber filled with 200 tons of water. Because if we can understand what dark matter is, we'll finally know what's holding the universe together. So there you have it, the story of how Fritz Zwicky discovered dark matter, except that's not exactly right. You see, Fritz didn't discover dark matter. Dark matter still hasn't been discovered. All Fritz did was propose a possible explanation for something he observed. And while he was widely ignored during his lifetime, he left behind a legacy that continues to inspire scientists today. Dark matter may not be the friendliest part of the universe, but it's certainly one of the most mysterious. And who knows, maybe one day soon we'll solve its secrets. Thanks for watching this video, and thanks to our supporters for making it possible.